Okay, welcome back. This represents what I've just talked about in my last video, the method of head to tail that is used to calculate a resultant momentum or resultant vector. I want to change a few details here. I want this object here, instead of it moving to the left, I want it to move with the same speed, but this time move to the right. You will discover that its momentum will now be to the right. That means that this arrow here will change direction and point to the right. And when I use the head to tail method of adding these lengths, I will connect the tail of this one to the head of this one here, and that is what I will get. This one will be how many centimeters? 25 centimeters. And the total length this time will be from where I started to where I stopped, and this length here will represent the total momentum in direction as well as magnitude. That is what will happen. So when the two objects are traveling in the same straight line but in the same direction, when you put the arrows head to tail, the resultant arrow becomes longer. When they are acting in opposite direction but moving in the same straight line, the resultant vector will be shorter, like we saw in the last video. So the total momentum here is going to be 55,000 Newton seconds to the right. Now in this video, we want to see what happens when they are not in the same straight line. They may be acting in opposite directions or different directions, but are not in the same straight line. What happens? But before I go away from here, suppose you're told the total momentum of this system is 40,000 Newton seconds, and momentum of one of them is 30,000 Newton seconds. What is the momentum of the second object? Obviously, you will know that it is 10 Newton seconds, and it must be acting in that direction, because you can see that the total momentum of the system is greater than the total momentum of this, the first body. Then the difference, of course, gives you the result. But let's look at a specific example pertaining to such a situation. Now, suppose you are given that there is a mass here, M1, whose mass is 20 grams, and it is moving to the right with a velocity of how much? Let us say it has a velocity u1 of 5 meters per second. And then there is another one here. There is M2, whose mass may be higher than that, 25 grams, and it's moving in this direction with a velocity u1 of, let us say, let's choose a velocity like 10 meters per second in this particular direction. And when the directions are such that they are neither horizontal nor vertical, they are in some other directions, at that point we usually use angles. So something like that. That one is the horizontal, and that angle is 30 degrees to the horizontal, like that. So this is M1, this is M2. And we want to determine the total momentum of this system. So let's first of all work out the momentum of the M1. We are going to call it P1. Of course, to the right is going to be equal to, this mass is 0.02 kilograms, and this is 5 meters per second, and that one will give us 0.10 Newton seconds, of course, in that direction. Let's work out the momentum P2. The momentum P2 will be its mass, which is 0.025 times 10, and this one will give us, multiply that one by 10, we get 25 divided by 1,000 is this much, multiplied by 10, we are going to get 0.25 Newton seconds, but in this direction, which of course makes the same angle of 30 degrees with the horizontal. This angle here is 30 degrees. You know, I've just extended this line like this, and since this is 30, this must also be 30, and it is the one I've used. And now I want to add these two momenta. Pt is going to be equal to P1 plus P2. And when you use the head to tail method, I'm going to have this one, which is 0.10 plus this one, which is a little bit longer and acts in a direction of 30 degrees to the horizontal, of magnitude 0.25 Newton seconds. Again, I go through the same motions of connecting them head to tail. Maybe it will not be so sharp here. Let me just reduce that a little bit so that this one can be a little bit slant. So that's it. I connect them head to tail. There's 0.10 and there's 0.25. This angle here is the angle that this vector makes with the horizontal, and it's going to be 30 degrees. And you can see that the total momentum is this one here. This is PT. It's at that point that we can now use cosine rule. We can use cosine rule for this particular question because this one is a triangle with the two sides which are known and an angle between them, and we want the side which is opposite that angle. The cosine rule says that this side squared, the length of this triangle squared, is equal to this length squared plus this length squared minus 2 times this times that. So let's see what that gives us. I'm going to work it out somewhere around here. So PT squared is going to be equal to this squared, 0.25 squared plus 0.1, and supposed to be minus 2 times 0.25 times 0.1 cos of 30 degrees. And I can be able to get the value of the total momentum Newton seconds. You can use the calculator to get that magnitude. So you can see it does not matter whether they are parallel. You know, we have dealt with a situation whereby they are in the same direction but on the same straight line. The second one was they were in the same direction but they were on the same straight line but in opposite directions. Now they are oriented to each other like this. How do you go about that? It's very simple. The same method. Work out the momentum of each one of them, and then when it comes to adding them, and this, by the way, it does not matter whether the vectors, they are 2 or more than 2. Work out the momentum of each one of them, represent them with arrows and maintain the angles, then connect them head to tail. When you slide one vector to the next so that the head of one of them is connected to the tail of the other, as soon as you get that shape, identify the first tail, that is where you started from, and the last head, the head of the last vector, which is this one. Then connect that first tail to the last head with a straight line. The length of that arrow will represent the magnitude of the resultant vector, while the direction in which it points, it will represent the direction of the resultant vector, the direction of the resultant momentum in this case. So in order to complete this working, you will work out theta. How do you work out theta? It's very easy. You can use the sine rule. You can say 0.25 over sine theta is equal to, now you get this one, is equals to pt, whose value now you know from here, over sine 30. This is the sine rule. You use the cosine rule to work out the magnitude of the resultant vector. And then you use the sine rule to work out any other angle that you might be interested there. Why are you interested in this angle? It's because you want to state the resultant or the total momentum of the system by stating the magnitude and the direction. In the previous two examples, we were not bothered with the direction because we know it's either to the right or to the left, so there was no problem. But when it makes any other angle, with the vertical or with the horizontal, that angle must be calculated. And this is how you work out the resultant vector when the vectors are not in the same straight line. Now in the next video, we are going to look at a situation where we just have one object. It has a certain velocity, and then something happens to it that its velocity changes. An external force is applied to it to make its velocity to change. In such a case, we are going to calculate change in momentum. Change in momentum. Notice here we had different bodies, each with its own constant velocity, and that velocity is not changing, and then at a particular instant of time we want to calculate the resultant vector, the resultant momentum of the system, the net momentum of the system. All those terms can be used. The sum of the various momenta, resultant momentum, net momentum of the system, all those terms can be used. So in the next video, we are going to see a single body whose velocity changes, and therefore we are going to be asked to calculate the change in momentum of that body. See you in the next video.